Hello everyone and welcome to our channel. Today we are going to see one of the basic coding skills problem, which is nothing but finding the nth Fibonacci term and generating the Fibonacci series. We are going to see two problems in this video. Observe what is meant by a Fibonacci term or what is meant by a Fibonacci series. A Fibonacci series will look like this. We will start from 0 and the next term will be 1, and then every next term would be the sum of previous two terms, which is nothing but see these two sum 0 plus 1. This would be my next term. 1 plus 1. This would be my next term. 1 plus 2. This would be my next term. 2 plus 3. This would be my next term. 5 plus 3, 8. Like this, every new term in the Fibonacci series would be the sum of the previous two terms. Okay, and we will take the first two terms as 0 and 1. Observe here, this is going to be the Fibonacci series, and in this Fibonacci series our task is to find the nth Fibonacci term, which is nothing but this is the first Fibonacci term, second Fibonacci term, third Fibonacci term, fourth, fifth. See, if the user entered 5 as an input, your task is to find the fifth Fibonacci number, right? Like this, you need to generate the nth Fibonacci number. Let's see the explanation part of it. The first and foremost thing was you need to initialize two variables, which is nothing but the first term and the second term. And if the user entered the n equal to 1, means he wants the nth term, means first term, then you directly print 0. If the user entered n equal to 2, means what? The first two terms, then in that case, or the second term, then in that case you directly print the f2 value. But if the user entered a n value greater than 2, which means a third term or a fourth term, like this, any nth term the user has entered, in that case you need to write a loop and you need to find out that term. Okay, and the logic for it is, see, for the term, right? For example, term equal to 2 terms has been done, and the remaining should be start from 3, from the third term, and term should be less than or equal to n, right? Nth term, n, and term plus plus. And what is the logic you need to do? The first and foremost logic is you need to sum up the previous two terms, which is nothing but f3 equal to f1 plus f2, which means the new term would be the sum of the previous two terms. It's done. Now our task is to change the remaining terms, right? For example, see 0, 1. This is f1 and this is f2. f3 is nothing but f1 plus f2. 0 plus 1, 1. Now our task is we need to consider this as f1 and this as f2 in order to compute the new term. So now new f1 would be the old f2, new f2 would be the old f3. Like this, if you continue this process, you will end up with f3 value, which is nothing but nth Fibonacci term in the series. Okay, now let me show you programmatically so that it would be clear. Okay, let's observe here. Our task is you need to read a number, right? Let me give a printf message so that the user will be clear with it. Please enter a number n. Okay, number n to find nth term, right? To find nth Fibonacci term. Nth Fibonacci term. Yes, the message has been entered. Once the message has been entered, we need to read it, right? We need to read the input whatever the user has given. Scanf %d. Why it's an integer, right? Ampersand of n. That's it. Now our task is what? First you need to check it out. Let me take the two terms, okay? Two Fibonacci terms. The Fibonacci term f1 is nothing but 0. Similarly, the second term is 1. That's it. And I need to declare f3, right? It's a new term, right? The next term, the immediate next term we need to find. Now here you check it out. If the user want the first term, we know the first term would be directly 0, right? So you directly write printf percentage d, comma f1. That's it. And if the user has given, else if the user has given n equal to 2, which means what? The user is asking for the second term. We know second term directly, right? First term is 0, second term is 1. Okay. Now let me print the same here. Percentage d f2. Now let's go for the remaining terms. If the user has given some input which is greater than 2, which means the third term or the fourth term or fifth term like this, in that case you need to write the logic here. See, for term, right? Let me initialize the term here. Okay, let me take up the term here. Term is a variable. Okay, now see here guys, we need to take the term, right? The term equal to, already two terms has been done. We need to start from the third term. For term equal to 3 and the term value less than or equal to n, term plus plus, like this up to this you need to calculate all the terms. Okay, and at last you will end up with the nth Fibonacci term. See, the immediate next term would be sum of the previous two terms, f1 plus f2. Once it done, you need to change the f1 value as previous f2 value, and similarly the f2 value as the previous f3 value. Okay, now see, by doing like this you will end up with the nth Fibonacci term. Okay, now let's observe here, f1 value is 0, right? And f2 value is 1. Now similarly take it here, f3 equal to nothing. Okay, initially. Now see, if I want to find the fifth Fibonacci term, observe here, term equal to 3. Yes, term value is 3, for example. Yes, 3 is less than or equal to 5. So f3 equal to f1 plus f2, 0 plus 1. f3 would become 1. f1 equal to f2 means f1 value you need to replace it with the f2 value. f2 value you need to replace with f3 value. It will become 1. Done. Now term will become 4. Yes, 4 is less than or equal to 5. Again, f3 equal to f1 plus f2, 1 plus 1. f3 value is 2. f1 equal to f2, f2 equal to f3, right? f1 equal to f2. Yes. f2 equal to f3 means f3 value is 2 now. So that's why you need to place it 2. Now term will become 5. Yes, 5 is less than or equal to 5. f3 equal to f1 plus f2, 2 plus 1. f3 value would become 3. f1 equal to f2 means it would be replaced with this. f2 value will become f3. f2 value would be replaced with 3. Now see, when our term becomes 6, 6 is less than or equal to 5. Now it comes out of the loop. Now see, f3 is holding the nth Fibonacci term, which is nothing but the fifth Fibonacci term is 3, right? See, 0, 1, 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3. See, 1, 2, 3, 4, 5. This is the fifth Fibonacci term. That is what we got in f3. Okay. Now at last, I'm going to print the f3 value. Okay. After completing this for loop, I'm going to print the f3 value. That would give me the nth Fibonacci term. Let me save this code and let me execute. Okay. Let me execute here. Hold a minute. Let it compile. Yes, it's done. And asking the user to enter a number, right? I am giving 5 as an input. See, the fifth Fibonacci term is 3. Okay. Now for better understanding, let me put like this and let me execute one more time and let me do it here. See, I'm going to give, for example, an 8th Fibonacci term I need. 8th Fibonacci term is 13. Why? 0, 1, 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 5 plus 3, 8. See, first Fibonacci term, second, third, fourth, fifth, sixth, hold a minute, 7th, and then 8th Fibonacci term, 8 plus 5, 13. This is the 8th Fibonacci term, right? 8th Fibonacci term. Like this, you can able to find out nth Fibonacci term easily, okay? Easily by taking this loop. Okay. Now, let's go for the next problem, a small variant of it. Say this problem, they will give you a limit and your task is to generate all the elements within that limit. Okay, all the Fibonacci terms, just like a previous one, but here the task is only one thing you need to add. If f3 value is within that limit, right? If f3 value, whatever the f3 value we computed as a part of the previous code, If it is within that limit, then we can directly print the F3 value. So we can know that yes, it is inside that limit and it's a Fibonacci term. Okay, let's check it out how to do it. Let's check it out. See guys here, and I need to ask the limit, right? Limit. Okay, enter the limit. Okay, enter the limit to generate Fibonacci terms. Okay, or the Fibonacci series. Now he will give you the limit. Okay, no problem. He will be given a limit and I need to read into the variable called limit. Yes, it's done. Now, for example, if the limit is 1, means what? I need the Fibonacci term. For example, if the limit is 0, for better understanding, means I need to generate the Fibonacci terms within the limit 0, means only F1 is possible, right? So that's why I printed it. If the given that if limit equal to 1, limit equal to 1 means, hold a minute, if the limit equal to 1 means what can I able to generate? If the limit equal to 1 means I can able to generate 3 terms, right? 0 1 0 plus 1 1 means F1 F2 and F3. Up to this I can able to generate, right? So let me do that. First one is I can able to print F1 and then, hold a minute, multiple statements, right? That's why I need to take the curly braces. Now inside it, first term I can able to generate and second term is my output, right? F2 done, and the next thing is what? F1 plus F2 is also possible, right? F1 plus F2, 0 plus 1 1. So these are all the values I can able to generate. Now see here, if the limit is some beyond the 1, means some 2 3 some 20 30 like that, if the limit is gone beyond it, you need to use some formula or you need to use some logic here. See, I'm going to take an infinite loop. Okay, while of 1, it's an infinite loop. Now immediate task is what? I'm going to check it out, F3 equal to F1 plus F2. Yes, I computed the next immediate term. Okay, done. Now see here, if whatever the F3 value I have been computed, if it is less than or equal to limit, means what? If it is within the limit, what I can able to do? I can able to do F1 equal to F2 and F2 equal to F3, and then I can able to continue. And for the time being, if F3 value is gone beyond it, if it is gone beyond it means I can break the loop, right? I can break the loop, no more to go again. See, for example, limit has been given as 8, for example, and I'm going to generate the Fibonacci series as 0 1 0 plus 1 1 1 plus 1 2 2 plus 1 3 3 plus 2 5 5 plus 3 8, done. Up to F3, see, this is F3 value within the limit. Now 8 plus 5 13, 13 has gone beyond the limit. When F3 is greater than limit, then immediately you break the loop, you come out of the loop. Okay, that's it. Now meanwhile you can print out all the F3s. Okay, printf percentage %d F3. Okay, now for a better understanding, hold a minute, and I will put a \t everywhere so that it would be more clear. Okay, let me put a \t, okay, or \n so that it would be more clear. \n, okay. Here also I need to print it, right? Percentage %d \n. Yes, it's done. By doing like this, every output would be printed in a new line so that it would be clear for you. Now again, \n everywhere. Now whenever you got out of the limit, you will break the loop and you will stop your process. Okay, let me save this code and let me execute the code. Let me execute the code here. See, what is the input I need to give? I need to give a limit, right? Let me give the limit as, for example, 8. Yeah, now see guys, 1 2 2 plus 1 3 3 plus 2 5 5 plus 3 8 8 plus 5 13. Okay, what went wrong means, hold a minute, we will see like this, then it would be more clear. Okay, see, If the limit value is 1 means I can able to get up to this. Now if it is not the case, I need to print the previous ones also, right? So let me print it out and then we will continue. Okay, hold a minute, I will show to you. Yeah, you check it out. Yes, you taken the f1 values and f2 values, means 0 and 1 has been printed here. And then what you're going to do, 0 plus 1, it would be 1, right? F3 value would be 0 plus 1, it would be 1. F1 value is initially 0 and f2 value is initially 1. F3 value 0 plus 1. So it has been printed, right? So within that limit means it has been printed. And then you check it out here. Again, you f1 equal to f2 and f2 equal to f3. Means it would be 1, it would be 1, right? Now f3 equal to f1 plus f2, it would be 2, and 2 is within that limit, so 2 will be printed out. And then again, and f1 equal to f2 and f2 equal to f3, 2 plus 1, 3. So f3, 3, right? It would be within the limit, it would be printed. Now again, f1 equal to f2, f2 equal to f3, so it would be 3. F1 equal to f3 equal to f1 plus f2, means 2 plus 3, it would be 5. 5 is within the limit, so 5 would be printed. Again, f1 equal to f2, it would be assigned with 3. f2 equal to f3, it would be assigned with 5. Now f3 equal to f1 plus f2, means what? 5 plus 3, 8. 8 is within the limit. Yes, it's done, right? Now, hold a minute. We'll put this print statement here, okay? Then it will be more clear. Once you computed this, if this is within the limit, you print it out, otherwise you break the loop, okay? Now check it out. Let's check it out with an input of 8. Can you able to see the series, the Fibonacci series within that limit? Right, now let me check it out. A Fibonacci series or within 20. What would happen within 20, okay? Now within 20, can you able to see 0, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 8, like this. Let's check it out with another test case. And the test case, observe guys. Let me give a test case of 30 for example. See, within the 30, we will got all this series, okay? In this way, you can able to find nth Fibonacci term or any Fibonacci series easily. This is all about today's session, guys. Thanks for watching. Please do like and subscribe for more videos like this.